So that's actually how I got from this line to this. If you have something squared equal to 0, then that something itself, what you're squaring, has to be 0. It's just a basic property of math. Multiplication, that is. Okay, so we have this example. Okay, now here's another one. Now, this one, what I'm doing is using the quadratic formula, almost that is. So we have 1 over x squared plus 4. And we want to know when the denominator is 0. Right? Now, what I'm doing here is I think I said this before, but if you have x squared plus a positive number, like 4, this is actually going to be irreducible, meaning this will have no solutions. You can't factor it, in other words. And what I'm doing is I'm just confirming that using the discriminant of the quadratic formula. That should be a minus sign. Let me fix that. Remember, when you have the quadratic formula, you have b squared minus 4 times a times c. That's what's under the square root symbol. You might have to go back and look that over if necessary. But if that turns out to be negative, then this equation has no solutions. And that's what I'm using here. Basically, we have a is 1. A is the coefficient of x squared. B is 0. There's no x term here. C is 4. And if we did b squared minus 4 times a times c, okay, this turns out to be negative, and in that case, this has no solutions. That's something we have seen before. I think it was in 1.2 actually. So it's negative. No, excuse me. So since the discriminant is negative, this has no solutions, no real solutions, that is. And because of that, the denominator is never 0. So this function has domain, all real numbers. So again, if you tried the quadratic formula, this is basically telling you that you'll get the square root of a negative, which tells you this equation has no real solution. Hence the domain. Hence this thing is never equal to 0, and the domain is all real numbers. I really hope that made sense. Okay, let's do another one. Okay. Yeah?
Can you go back just a second?
This?
Yeah.
What's up?
No, I just need to finish copying the notes.
Oh, I did email it to you.
Oh, okay. Sorry.
That's okay. No worries. I mean, yeah, it should be in your inbox. If it's not, if you don't see it, please tell me though. Okay. Oh. Any other questions? Yeah. Okay. But I did email the notes to everyone. So it's not in the slide format; it's in PDF format. But, okay. Okay. So here we want to get the domain of this. Well, it's really just like what we saw before. We have a square root in the denominator, okay? And we want to know when the radicand, what you're taking the square root of here, when is this positive? Because it's in the denominator, we want to know when it's positive. And that's what I'm solving here. So what we do is we're going to add 3 to both sides, as you can see. Okay? And then what we do next, so we get 4x is greater than 3. Then we divide both sides by 4. right? Because we want to get x all alone. Okay. Then we get, and from there we get x is greater than 3 over 4. Again, we don't turn the inequality symbol around because we're dividing by a positive. And the domain we get is all x greater than 3 over 4, which means all numbers greater than 3 over 4. And that's the same as this. So any number in this interval, well, if you plug it in for x, you'll get the square root of a positive number. And hence, f of x makes. The domain remembers all your inputs. All numbers that go in for x that yield an output that makes sense. Okay. Okay, now this is another kind of example I thought that'd be good to do. Here we're just basically doing some calculation. And what I like about this is we're replacing x with specific numbers and doing the calculation. I'm doing this because in the past, students have had trouble doing these kinds of things. So I figured it wouldn't hurt to go through it. So I'm taking f of x to be this thing, okay? So f of x is this polynomial function. I'm saying here, calculate f of -2 and f of 3. Okay? Then I'm saying add those two outputs together. So how do we get f of -2? What I'm basically doing is I'm replacing x by -2, right? That's what I'm doing here. So f of -2, right? -2 is taking the role of x. So we get -2 squared plus 4 times -2 minus 7. Okay. And so we calculate that. So -2 squared is 4. 4 times -2, that's -8. So really we have adding -8, but that's the same as subtracting. Minus 7. And so we get -4 minus 7, which is -11. So again, f of -2, I'm replacing x here by -2. F of 3, it's similar. It's just that I'm replacing x now by 3. See? Calculating the outputs. So f of 3 is 3 squared plus 4 times 3 minus 7. So x is being replaced by 3. Okay. And that's equal to 9. 3 squared is 9. 4 times 3 is 12. 9 plus 12 minus 7, which is 14. So f of -2 we get is -11. F of 3 we get is 14. Now if you add these together, that's the same as adding minus 11 and 14, and that's equal to 3. So it's not really so much the arithmetic is why I'm doing this. It's really more the notation. I probably could have done although I guess I can draw it by hand. Let me see if that'll work. Let me see. So we have minus 2. Bear with me. Oh, man, I missed teaching in class. Under the wonderful function f is f of -2 and that is -11. And with 3, this is not in the notes I sent, so bear with me though. We get f of 3 which is the wonderful 14. Okay, I mean, I don't know if that helps or not. I mean, Hope I didn't plan on drawing that, but hopefully that helps a bit. Hopefully it doesn't hurt. Maybe that's better. Okay, so that's our first example. Let's try another one. So here, it's similar. However, the function, of course, is different. And now we're calculating f of 1, f of 5, and then we're subtracting. F of 1, again, we plug it in. We replace x by 1, right? It's almost like x is your, x represents the input, right? So 1 is our input, 1 goes in for x. We get negative 1 squared, okay, plus 1. So that's going to be negative 1 plus 1, which is 0. F of 5, same idea, minus 5 squared plus 5, as you can see, which is minus 25 plus 5, which is minus 20. The difference, that's 0 minus negative 20. That's the same as 20, though. And I just put this down here just as a reminder that when you do negative x squared, that's the same as, negative 1 times x squared. It's really not the same thing as this, though. I mean, here it wasn't as big a deal because you're doing 1 and 5, but this is just something to remember.